Hello, good morning, good afternoon. In this class, I can speak about the sediment sport. It's an important topic. You can always check and review for newspaper, book, and check it out for magazine, for important magazine to check because you need accumulate a lot of information. This is topic in the test and the quiz, the formulation and resolve several problems very for the first course. I begin comment the the sediment the sediment transport. The sediment transport is the moving about a particular sea or few road you can move for not several velocity or it's not very fast, it's very slow, it's very slowly for to pass between river, between lakes, between ocean and other fluid. For example, this here's the positive is very important and check it out the follow the next uh, PowerPoint. Follow what the transport sediments bear of particular roads, slide or bones allow between buttons. Second, suspend log, particular cargo button by fluid turbulence and grain collision. This specific pressure. For example, in this picture, the particular and southern on field road, you can check the rolling is a movement. The sun, for example, is a movement. Rotator for the different place. For example, in this picture, you can review the rope, the small rope change for different for different for different place, rotor, and the force in this part is different, and it's different force in this part. For example, in this part, in this place, you can check the new force, friction force, advance, the small rope, and traction transports. The particular is necessary to cross the river and practice the traction transport between the movement and the transport sediment is real for whatever river for whatever ocean or lakes. This is important. For example, check out this part of picture in interruption and saltation. Why? Why? Any student you can explain me for these problems in this picture? No. This problem is the particular is very small. It's very small, and the force is several of high forces that uh, interchange the force, interchange the friction, and there are the new force, for example. The force when the traction transport force is very high, is several in magnitude, is several high, is several uh, from the friction and from the gravity or gravity force. It's very few, it's very small, and you can check the moving for particular is an interruption and a subtension. For example, in this part of the picture is the seventh, probably in the seventh picture is the same, excuse me, it's the same problem, for example. The grains collision interrupted and citation, the particular so for several child for the cross the river, cross the free world. Suspend allows intermittent suspense. What is the intermittent suspense? Anybody student that can answer me this question? What is this intermittent suspense? Intermittent suspense is the collision event. For example, in this part, you can check whatever thing. For example, potato, fish, and other animals or plants. Yes, plants. Whatever things. And if the sense is sense or similar in the small or similar for the size. It is similar for the size about the rolling, about the sliding, about the small particular. But the size is similar, for example, 2 p.m., 2 p.m., 5 p.m. in the scales. Continuous suspension is this part in this picture is very easy. It's only fluid, no more. And next example is not is okay. It's another students. Yes, it's a student you can get out for a new practice or the next test. You can get out for a lot of different sizes and different masks. Yes, it's a river. The river there are in water. There are water and the plants and the other animals. Civil construction, mechanical fluid, and the fluid. Check it out. What is the significant or grain size? Is control or grain moving during below transport? Control or grain moving during below transport? Yes. Yes. What do you sedimentary structure tell us about flow conditions? What is the question is very important. You can check the picture. Your picture, the top picture is different, but this picture is most important, and you can check details about picture, details about products. That is important. For example, the other time the question: what do sedimentary structure tell us about flow condition? Why do you sedimentary structure tell us about flow condition? Relationship between bare form type and form conditions. Relationship between bare form type and flow condition. The flow condition is not another flow condition. This is the grain size. The N is 1 millimeters. Is the problem, is the question for finish presentation, you can as well, and the papers give me for clarification. This next picture, please. The picture is important. Person, check it out. What force add on sediment grain in the moving fluid, forcing higher ammonia, forces promoting movement. The mu is letter is the same for velocity, yes. It's the same. According, yes. And this particular there are 3 forces the lift force and fluid force and the gravity force. There are other and particular force. You can check the pictures are very clear. What is the friction and electrostatic friction and electrostatic force. As a force is very complicated share for 1 meter, 2 meters, or for 100 meters. Is very difficult to check and recognize the force back to this force there are in whatever case, for example, in sediment transport. Yes. This picture or in this PowerPoint, you can simulate what is about what is a student you can explain. You can explain what about this picture. What about check, for example, and we will try to find the answering, please, and we will try. There are involuntary. For example, the velocity is the gradient. Is the gradient is the is a vector condition you can resolve for different problems about in general electric and mechanical engineering and civil engineering, because the simulation you can compare the real situation with the digital situation or simulation graph. For example, the colors very blue and black. Blue and black is negative velocity. For example, 15 centimeters per second and 10 centimeters per second and 0 centimeters per second. Cross between 0 numbers, 10 centimeters second and 20 centimeters and 45 and 45 and 50, 55, 16 and 90 centimeters per second is a high velocity. The velocity is relationship between images, the relationship in images. The energy is the equation you can mix, in this case, velocity and vectors. For example, mu is the velocity. This ball is white. It's white color because there's different for different colors and different force. In the simulation graphic, in the simulation presentation, you can define colors. The color more clear is the rock, and the color more black is less velocity or capacity. Yes. The question is very simple, and the resistant force due to inertia. Fluid acts gravity, forces in the movement, force in primary movement. Check. And force are force massa multiplied with gravity. For this picture, there are particular situations. Simple mass per gravity, but dry mass is our. Replace mass by volume and density, and combine constants into single term else. Check. Force for per 3 P radio elevated and 2 powers break a density degrees less. Check Density of the fluid, black, multiplied for the gravity. Gravity, no, is acceleration, gravity. Yes. In other equation, you replace for, for radius for diameter. And S plus 1 is determined singles. The density is the same equation, is the same. Gravity is the gravity, is no change, but it's only letter as letter, no more required. When the mass is very big, for example, 100 per 100%. Between comparing 10 to a 1 or 100 to a 1 is there are a lot of height is for this case is huge difference. The next is more easy. No, it's more complicated because you can check the rules, include lags and gravity, force and hydromobiles and force per mobile. There are two types about the force. Free velocity necessary to carry more force. Energy plus force in relation to the distance and the density for free velocity. The other equation is the same because there are force between force handling moment and force primary moment. The velocity is necessary to create moving force. Is necessary. The velocity necessary to create moving force. Next. It's the same teacher. An initial also grand movement. Inertia is the way of the drops. So there are for the service. The problem is the force and in this equation the problem is the FR. You can combine and you can combine the equation and to find when you can combine the equation. The equation for the constants or variable letters is new, is similar velocity. You can see a square root for argument is about relation density, grain density, fluid density, another fluid, gravity acceleration, and the length and the diameters. This picture you can, for the student, review because the diagram, for example, flow velocity, 7 minutes per seconds, and all distance, the other distance is a difference. It's a different size, a different ball, for different grain size, for example. It's the same millimeters, calculating millimeters in the equation, and we solve, compare for different results, and report the next steps. Relationship doesn't apply and the fine grain size because the shear criterion doesn't account for friction or electrostatic force. The square is the maximum particular size T that can move for the velocity, calling the competence of the flow, shown by Houston diagrams. in the picture, flow velocity plot, and the right side measurements. The lines across the picture is transport after motion initiated. The position, erosion, transport after motion initiated. The different gradients explain size, sounds, and granulated cobalt. Fluctuate current, velocity, and natural setting, resulting in the altered erosions and transport with the position, changing confidence and capacity. This is the main reason why the sedimentary rocks are reliable. The next question, the students and the for new groups investigated for the worst erosion and transport. The place, the spaces of what is the condition you can resolve several problems with this situation. What is the other investigation is about well, the different types about the position and relationship between the position and erosion problems, relationship the position, the transports for different three results and the three graphics and the dialogue. So thank you very much for the teacher.